Friends, very good morning to everyone. We were dealing with the coupling agents to activate the carboxy group to an activated esters. We have seen carbodiamide mediated coupling, its advantages along with its limitations. To overcome the limitation, other types of active esters are prepared by using another type of coupling reagents. That is the subject of the discussion for today's presentation. We can prepare active uranium esters from carboxylic acids. To prepare this active uranium esters, we use coupling reagents that are belonging to the class of tetramethyl uranium salts. They are HBTU and HATU. HBTU is the shown here. It is hexafluorophosphate derivative. That is hexafluorophosphate benzotriazole tetramethyl uranium salt. The HATU is the isoster of HBTU. The benzene ring, the one of the carbon here is replaced by nitrogen in HATU, HATU. Here you see the nitrogen, the carbon over here is replaced by nitrogen and it gives HATU. HPTU converts to HATU. What is this HATU? Hexafluorophosphate azabenzotriazole. Azabenzotriazole tetramethyl uranium salt. Instead of using carbodiamides as the coupling agent, we use HPTU and HATU in its place to create active esters which are uranium esters. Why HATU and HBTU? This enables the reaction very quickly. Hence, the reaction kinetics is very fast compared to carbodiamide coupling. Not only it is quicker, DCC mediated activating of the esters has extensive purification steps where DCC which is formed we have to remove HOBT, HOAT which are used it should be separated and it gives other side reactions and these are not found in this HBTU and HATU. That's why it increases the reaction yield. It is not only quicker but also give better yield. Further, it has the byproducts which are formed which are more water soluble and hence it is easy to separate from the desired products. Easy workup procedure, easy reaction procedure and better yields what we require for the better reaction. Yes, it also suppresses the racemization, which is the common phenomena which we see in DCC and DIC mediated coupling. The reaction undergoes at more ambient reaction conditions using the milder bases like diisopropyl ethylamine and milder temperature condition. That's why uranium esters preparations are preferable over carbodiamide esters mediated preparation. How this reaction occurs? Let us look into it. Hexafluorophosphate benzotriazole tetramethyl uranium HBTU. The OH Lone pair of electrons attack on this carbon, a positive center at is flanked between three electron withdrawing groups, and it has to maintain its tetravalency. Pi electrons moves and the bond breakage occurs, and the N-hydroxy benzotriazole moves out to give the corresponding imide. This O minus of the OH of the benzotriazole attacks on the carbonyl carbon and kicks off this group as urea and gives benzotriazole derivative of the amino acid. Here also we got benzotriazolyl ester like that of dicarbo DCC or DIC, but using only one coupling reagent. No coupling additives are required. In fact, they have combined the benzotriazole HOBT with the imide to get the corresponding HBTU, which has the specific advantages over the coupling methods of DCC. HA2U also has the similar method of coupling. O minus attacks on the positive center, the benzotriazole group moves away, and O minus in the azabenzotriazole attacks on the carbonyl group and it removes as urea, and benzotriazolyl esters are formed which can be reacted with. This is an activated ester which can interact with the amines of the amino acid to give the peptide bond. Uranium based reagents are exceptionally stable in dimethyl formamide as the solvent. That's why it has better advantages over DCC coupled activation of carboxy group. This also has its own limitations. It also has its issues. That's why instead of this, we can prepare active phosphonium esters from carboxylic acids, which are also active esters. Another method of activating the carboxylic acid is preparation or generation of active phosphonium esters from carboxylic acid. The coupling agents which we use are benzotriazole phosphonium salts, BOP or PIBOP. BOP is this. BOP stands for benzotriazolyl oxy dimethyl amino phosphonium hexafluoride. PIBOP. Instead of this dimethyl amino group attached to the phosphonium group, this has been replaced by pyrrolidine group to give PIBOP. PIBOP stands for benzotriazolyl oxy tripyrrolidino phosphonium hexafluorophosphate. These are the two coupling agents which finds its use to prepare active phosphonium esters from the carboxylic acids of the amino acids. Compared to uranium esters, its racemization potential is lesser. That's why it has its advantage of preparing the purer product. Further, these reagents are more stable in reaction condition than that of uranium salts. It forms lesser decomposition products than HBTU, and that's why it increases the yield. The HBTU or HATU is susceptible to side reactions, especially with aminopolymers, and that is avoided in this phosphonium salt's utility. Hence, this also adds up to increase the yield of the product. Phosphonium salts are more soluble in almost all the common solvents than that of uranium salts. Hence, it has its own advantage, and it is more versatile. It is more also suitable for both solid phase and solution phase synthesis, whereas uranium salt esters are more suitable for solid phase synthesis. Owing to its versatility, solubility, stability, and lesser side reaction, lesser racemization potential. It has these own advantages, and it are also specific in reaction. It is more specific than that of uranium salts. It is particularly more reactive in N-methyl amino acid coupling and also in certain microlactonization reactions. How this interacts and form the esters, let us look into it. Bob protection. The phosphonium group is the positive center. O minus in the carboxy group attach on the phosphonium, and the bond between phosphorus and oxygen breaks, releasing the N-hydroxy benzotriazole. The released N-hydroxy-benzotriazole O- attack on the carbonyl carbon of this ester, and this is the bulkier group which can be easy leaving group. It leaves dimethylphosphonium oxide is removed as a byproduct to give benzotriazolic ester. Here also the same benzotriazole derivative is found by using phosphonium hexafluorophosphate salt, like that of carbodiamides or that of uranium salts activation. This has the potential as an active ester to interact with the amino group of the amino acid to form the peptide bond. The PIBOP is also having the similar mechanism. The phosphonium phosphorus it attacked by the lone pair of electrons on the oxygen, benzotriazoxy removed, which attacks on the carbonyl, and tripyrrolidino phosphonium salt is removed and gives benzotriazolyl oxy ester. Overall, the coupling kinetics is better in both uranium and phosphonium salts than that of carbodiamides. That's why it has faster reaction and quicker reaction and clean reactions. Phosphonium salts are moderately stable in DMFs, which has to be kept in closed vials, and it can be used only for 2 days. After that, it decomposes. Compared to the uranium reagents, the phosphonium reagents give cleaner reaction. That's why phosphonium reagents are preferred over uranium reagents are preferred over carbodiamide reagents. We have seen about the protection of amino group, protection of carboxy group, and activation of the carboxy group for peptide formation. Next presentation, we will continue with this. And what are the strategies utilized in solid phase synthesis will be the subject of discussion for those presentation. Till then, have a nice day. Thank you.